Hey, welcome to the 20th session of the Flipped Classroom for AP Calculus. Tonight's discussion is on the second part of section 2.9, derivatives of exponential and logarithmic functions. Let's talk about the derivative of a to the x, where a is some constant but not e. Remember that a to the x equals e raised to the x times natural log a of power. Don't remember that? Well, it was a long time ago and it was in the preliminary chapter. Let's see if we can figure it out again. Let's let y equal a to the x. Now take the natural log of both sides. So I have the natural log of y equals the natural log of a to the x. On the right side, we're going to bring the exponent x down using properties of logs. So it gives me natural log of y equals x times the natural log of a. Using the inverse property of logs, I can come up with y equals e to the x natural log of a. But since y equals a to the x, as we said in our first statement, a to the x can be written as e to the x times natural log of a. So now, to find the derivative of a to the x, all I have to do is take the derivative of e to the x natural log of a. To do that, we need to use the chain rule. We're going to let u be x natural log of a. U prime would be just natural log of a. And the outside function would be e to the x natural log of a. So the derivative of e to the x natural log of a would simply be natural log of a times e to the x natural log of a. But remember, e to the x natural log of a equals a to the x. So the derivative of a to the x is simply natural log of a times a of x, a to the x. If u was a composite function of x and we had a to the u, the derivative of a to the u with respect to x would simply be the natural log of a times a to the u times derivative of our inside function u prime. Sample problem. Let's say y equals 9 to the negative x. Find y prime. I'm going to let u be negative x. So u prime would be negative 1. A would be 9. So y prime would be the natural log of 9 times 9 to the negative x times negative 1, or negative natural log of 9 times 9 raised to the negative x power. Not so bad. The derivative of log base a of x. This would be some base other than e. So we don't know what the log is. We're just going to say it's some base. Once again, remember that log base a of x equals natural log of x over natural log of a. This is known as a base conversion property, and it was in our preliminary chapter. If you don't remember, here's a brief explanation. If y equals if y equals log base a of x, then a to the y equals x. Where do I get that from? The inverse property for logs. Let's take the natural log of both sides of that equation then, and I come up with natural log of a to the y equals natural log of x. Okay? Bringing the exponent down on the left side gives me y times natural log of a. The right side still remains natural log of x. But y equals the natural log of x over the natural log of a, so I can substitute that in. Okay? So substituting that in, I solve for y and I get y equals natural log of x divided by natural log of a. But y equals log base a of x, which is our first statement. So substituting that in for y, I get that the natural log of a, base a, of x equals the natural log of x over natural log of a. Okay, this would be a conversion property for logs. So now to find the derivative of the log of log base a of x, I simply take the derivative of natural log of x divided by natural log of a. Okay? And that is 1 over the natural log of a times 1 over x, which really is 1 over the natural log of a times x. Okay, Now that you're thoroughly confused, let's try a sample problem and maybe it'll be a little easier. Let's say that y equals log base 4 x squared. Find dy dx. The first thing I do is I rewrite this as 2 times log base 4 of x. I can do that because 2 is an exponent and I can bring it down as a coefficient. So therefore dy dx would simply be 2 times 1 over the natural log of 4 times the natural log of x, using our conversion formula from the previous slide. Okay, one more thing to talk about, logarithmic differentiation. Let's say we have a problem y equals x raised to the natural log of x. Notice we now have a variable in the exponent. In order to find the derivative of that, we have to use a technique known as logarithmic differentiation. First step, take the natural log of both sides. So I get the natural log of y equals the natural log of x raised to the natural log of x. I still have the natural log of y, but on the right-hand side, I can bring that exponent down as a coefficient, and what it gives me is the natural log of x times the natural log of x. Okay? Think of the natural log of x times the natural log of x as natural log of x squared. So now I'm going to take the derivative implicitly. The left-hand side would be just y prime over y, because that's the derivative of natural log of y. The right-hand side, using chain rule, would be 2 times the natural log of x times the derivative of our inside function, which is the natural log of x, and that derivative is 1 over x. So y prime, therefore, would be 2 natural log of x divided by x times y, and remember, y is x times the natural log of x. Practice problems. Please work on page 231, number 31 through 40, and 41 through 48, or you might say 31 through 48. Thank you and have a good evening.